The next question is question number 9. And question number 9 says, Observer X sees a spacecraft moving in the positive X direction at a speed of 0.5 c, where c is standing for the speed of light. Observer Y sees the same spacecraft moving in the negative X direction at a speed of 0.5 c. So mind you, these are two different observers observing the same thing here, which is a spacecraft. Now, they both agree on the speed at which the spacecraft is moving, but they disagree in terms of the direction that the spacecraft is moving. What the question wants us to find is, what is the speed of y in the frame of reference of x, or what is the speed of y in the reference frame of x? Alright, so this question falls under Galilean and special relativity. It's a very interesting question. Let's quickly jump into the solution. Now, the first thing you have to know is what a frame of reference or a reference frame is. And a reference frame or a frame of reference, they mean the same thing. Refers to a coordinate system used to describe the position, the velocity, and orientation of an object. All right. Now, three key features we can pick from a reference frame or a frame of reference is origin, axis, and time. Origin refers to the starting point from which all measurements are taken. So if we are taking a measurement, we have to start from a certain origin, or we have to start from a certain point, and we are calling that point our origin. And we have to also measure that with respect to axis, and these axes are x, y, and z. So that is a three-dimensional coordinate system. Okay, and this three-dimensional coordinate system, which is x, y, and z, indicates the directions in which we want to measure our position and our velocities. And we need to measure time, so we need a clock to measure time. Now, going back to the question, we have two observers, the observer X, observer Y. So from observer X's reference frame, the spacecraft moves at 0.5 c, and that is in the positive X direction, so we denote that speed with a positive. And from observer Y's reference frame, the spacecraft moves at the same speed, which is 0.50, but then in the negative X direction, so we denote that u prime to be equal to 0.5 c. Now we want to find the speed or velocity of y in the reference frame of x. Okay, and we are saying that we want to let that value for speed or velocity be v. What you should note is that u prime is the speed of the aircraft as observed from y's reference frame. That is not the same as the speed of y. That is a speed that y is observing the spacecraft to move with or at, but that is not necessarily y's speed. What the question is asking us to find is to find the speed of y now in x's reference frame. All right, so using Einstein's relativistic velocity addition formula, we can write an expression for the speed of the aircraft from y's reference frame, where we can end up inputting the speed of y in x's reference frame. So we can write that minus 0.5 is equal to 0.5 minus v. V is y's speed in x's reference frame. V is y's speed in x's reference frame divided by 1 minus 0.5 multiplied by v divided by c squared. And when we simplify this, we are getting an expression of what we have here, and that is 0.5 here minus 0.5 is equal to 0.5 minus v over c divided by 1 minus 0.5 v over c. So we want to just write a simplified expression where we can end up getting our v. So we say that let alpha be equal to v over c. Okay, so we input alpha there, and when we simplify, we are getting our alpha to be 0.8, but we know that alpha is given as v over c, so making v the subject gives us v is equal to 0.8 c. So this 0.8 c is the speed of y in the reference frame of x. Speed of y in the reference frame of x. And I'm repeating here again, the speed of y in the reference frame of x is not the same as the speed of the aircraft in y's reference frame. again, the speed of y in the reference frame of x is not the same as the speed of the aircraft in y's reference frame. Okay, rather it is the speed of y as observed from the reference frame of x, and that includes how v is viewing the aircraft. Okay, and that is u prime. All right, so our answer for that v is equal to 0.8c. Now let's switch back to our question and see which one is our answer. Now looking through the possible answers we have here, A, B, C, and D. Obviously our answer is B.